Hello, good afternoon. This is Piotr speaking again. In part 12 of the Quasar Training 2020 update. And in this part, I'd like to familiarize you with methods. So methods, let's talk about OPC-UA methods. So a method is a node in the address space which can receive call service requests, which means you can call a method. This is what you do with a method. Not very shocking. It's like in object-oriented software engineering. So the primary application, the way of thinking about methods, and especially when your OPC-UA address space represents a existing system, like a control system or monitoring system, is that you want to invoke an action on an object. So normally you would use verbs to name your methods, and the verbs could be like turn on, turn off, or reset maybe, or start, or stop, or I don't know, stretch, whatever, explode. That's not really. I just gave you a few examples, but the point is that you invoke an action on an object. Okay, so you never call it by nouns, I suppose, and OPC-UA methods are kind of separated. So a method is not really by OPC-UA linked to a specific object or a specific object type. Of course, that is the most natural way of thinking, but OPC-UA goes beyond that. However, in Quasar, we support only methods which are bound to an object. So you see a method that belongs to a particular object, and when this method is invoked, it acts on that particular object. Then Quasar supports synchronous and asynchronous calls. Well, OPC-UA does not really make any difference here. So for OPC-UA, a call is just a call with this or that timeout. In this part, though, we cover synchronous methods. Okay, what means asynchronous, actually we'll learn in one of the next parts. And we do support any number of arguments and any number of return values. And for your information, the terms used in OPC-UA are rather input arguments and output arguments. And I found this to be a bit weird, so that's why in Quasar I designed it to be return values. And important statement here, so methods as of today, and I think it's January 2020, seem not to be supported by WinCC-UA OPC-UA client. So I'm showing methods because they have numerous applications, and especially when we go to UA objects and C++ clients, and maybe I also cover some Python clients. But if you think on profiting in WinCC-UA, then well, you'll be slightly disappointed. So I think methods are one of the most intuitive things you can do in OPC-UA and Quasar. So maybe let's get to a real example. So as you can see, here I have our Eclipse, and I thought it would be a nice idea. So if we kind of get back to our design diagram, so that was, I think, like that. Yeah, so that is where we left off, and so I thought it would be nice. So we have the motor class, and I thought it would be nice to have a method called turn on, which will, just invoke the action of turning on, which means, the motor will start spinning on a particular motor. And I thought that when you turn on, maybe you want to give a rotational speed, which is, like the set point. So you say, I want to turn on this motor with the intended speed of 200 RPMs or something like this. Okay, so let's get going. Let's see how to do that in Quasar. So we have our class name called motor, and then, or let's say there. Sorry for my English. I know it's far from perfection. We add a method, and well, we need to find a nice name. So I already told you. I think turn on makes a lot of sense. Synchronous, we keep it default, and then I told you we'd like to add an argument. For your information, you can add arguments, return values, and of course documentation. But what I'm doing right now is I'm adding an argument, And double makes a lot of sense, and I would say rotational speed set point. Okay, so let's see how this actually looks on the Quasar design visualization. So for all of you who know a bit about UML and the rather standard notation, this actually resembles UML. So we have this info method. Okay, this is not UML, but still, I think you see the pattern. Turn on, takes the double, returns nothing. Okay, as simple as that. All right. So let's. So as you expect, a method will need a place where we gonna put our code with the implementation, with the body of the method. And as we've been doing that with the delegated rights in one of the previous parts, I think it was part 5 or 6 or something, the handler was in the device logic of particular class. So since we added the method into motor, then now we have the demotor, and for instance, we had write rotational speed set point, and you probably remember when we've been adding this. So this is also where you will find our method, and of course you don't write it. You ask Quasar to help you out. So what you do is you again ask to regenerate the device logic of motor, and then our usual thing, which I can swear to you will be improved one day. Call turn on. Okay, so this is I'm pressing Ctrl 2. If it doesn't work, check what's your shortcut. But I'm taking the right pane, which is the version B, which is the new thing called turn on. As you see, those are delegated for methods, and everywhere else I choose what was before, and then in the body I simply go to my so what I will do here, I'm gonna press 1 and 1, okay, because this leaves the previous code here intact, and then I simply take this new handler, which you can see here, and I paste it there. Okay, voila, just that. And of course I choose A for all unsolved conflicts. Okay, this is sufficient, and now you can see in my demotor I should see. Sorry, what happened here? I'm slightly lost. I have call turn on. Oh, didn't I save it? I thought I saved that. Let's see. So there I take. Okay, looks like I didn't save it. So this is what I'm taking. Where's my? This is demotor H. Okay, so I don't really have to. This I don't have to modify, but I noticed I probably made a merge error in this one. And why? Okay, so here I again copy. Voila. Okay, I think I understand what happened. So when I do merge, choose A for all unsolved conflicts, and then let's see if that was actually properly chosen. Okay, I see what happened. It was in the place. I pasted it in the place of where there was a div. So that's why it thought, okay, take everything. So now it should be fine, I think. So I'm saving, I'm quitting, and I'm doing Quasar build. Okay, so let's try to run it, and let's connect with UA Expert. Voila, connect, and what we see now is motor, and we see something like that. It's a violet icon. Turn on. You can of course unfold, but this is not that interesting. You see there's it's called an OPC-UA property. Input arguments not really relevant, or not really that much relevant for you, unless you can read this information, which maybe we cover one day, but it's not really the time for this. But what you see is turn on method, and you can call this method from UA Expert, and what happens here is it asks you, hey, for all the input arguments, it asks you about all the input arguments. So rotational speed set point, I say it's 500. And what happens? Not implemented. And this is not very shocking because in our code, it's really not implemented. Voila. So here's what I'll do. Just to have a nice example, I will slightly extend our stuff here. And so what I will do is I will have here just to give a kind of a simulation of a motor which kind of spins up, spins down. Is actually correct in English. Spins down. Well, I'm not sure, but you know what I mean. So I will keep here a W, which is the current rotational speed. Rotational speed. Voila. And just to resemble a real physical motor, in update, instead of publishing some random value, I will actually do the following. I will say that my new sample of rotational speed is a part of the previous rotational speed and a part of current set point. So this is what? This is get rotational speed set point. Okay. So I think you can easily imagine what happens here. It's like a geometric series or some IIR filter, a very simple IIR filter. So this will kind of simulate exponentially the a state achieving the set point. And I want to publish the new rotational speed, right? This is what I want to do. Rotational speed, correct? Okay, and then in the method itself, I thought it would be nice to do the following. So if I see that the motor is turning, I would not like to let this finish successfully, because it's like, well, I want to indicate the user that there was really no point in turning on because it was already spinning. So what I'll do is, if the rotational speed is something bigger than, say, 0.1, which would be, the threshold for actually spinning. Okay, this is super slow, but still. I want to return OPC-UA, and there you have a selection of codes. So I think invalid state would be the nicest here. Okay, and if not, here you could send turn on command, and then you could do get other space link and set rotational speed set point. Okay, to the rotational speed set point and OPC-UA. Good. Okay. So it means when I turn on, if it's not turning on, okay, or if it's turning on already, I will say, okay, this is invalid state. Then I will send the actual turn on to the motor, and then I would the argument which was going along the call request will be actually set, to be taken into account by your system, by your hardware, by your API. Imagine whatever could that be. So I'm saving this. Let's try to build our server. Okay, now let's see how it behaves. So I'd like to subscribe to rotational speed and rotational speed set point. It stays at 0, not very shocking. And then I would like to call my turn on, and I say turn on with a speed of 500 RPMs, and voila, it's spinning. Oh, it's a nice simulation. You see my point. And sorry, and then rotational speed, blah, blah, it's 500, and now I will say 0, just to, say I'm turning it off, and voila, it stops. So, so I think the basic example of a method, you see how it looks like. You can imagine like other methods like reverse direction, or maybe, I don't know, break, or something like this, verbs, which indicate an action. you know. So just to explore it slightly more, I wanted also to show you about output arguments. Output arguments, I think it's more proper accent. So if you say add after, if we add another method, and then we say, so this one I would like to exercise, you know, the argument. So sorry, the return values. So I would say get diagnostics, for instance, and then I'll add a, you know, like a one return value, which would be like UA string serial number, and another one I think would such that we could download. Okay, as actually before, but that's not a big deal. Such that we could actually download the firmware, for instance, from the motor. Yeah, it's, you know, a nice example for a guy with a bit of electronics background, so I hope you understand. So my point is, I will be calling this get diagnostics, and then I want to fetch from the motor the current firmware. You know, it's like a binary object, you know. Imagine a few megabytes of bytecode for given, you know, processor, controller, whatever that is, and then some UA string with a serial number. Okay, so I'm saving the design, and again, what I do is I, of course, generate device, and the new date I'm taking, and I'm taking the new methods delegation, and then A for all unsolved, and voila. And then I'm going to our delegator, so I keep as it was, but then I actually take get diagnostics, which is my new thing, and I'm adding this, and I take choose A for all unsolved conflicts. Then I build that, or maybe before, before I build this, actually let's add the implementation. We'll save a bit of time. So I have, again, the same thing happened. Sorry, apologies. Actually, I was trying to find a simplest method to for this tutorial, but I think my older method was much better. So sorry for that. Anyway, so here we want to leave that thing. Okay, now it looks much better, I think. And in all remaining, we choose A for all unsolved. Let's see. Does it look good? No, of course it doesn't look good. So I don't know what I'm doing here. You know, it's a bit of stress, you know, this training. Yeah, this makes sense. And now we have call get diagnostics, which is not implemented, and the rest stays like it was. Okay, now it should be much better. So let's build it. So of course, then we can. So then we have call get diagnostics. So this is what will happen when somebody calls get diagnostics. So what I'm doing here, I have to kind of put some information back here. So firmware as bytes, let's say, and I'll use this new fancy way of initializing in C++. I don't know, like, doesn't really matter. And then I do firmware set byte string, I think, and then I have size of firmware as bytes. And here, don't kill me. Of course, I know I should divide this by firmware as bytes, element number 0. I know, but I'm trying to really keep it concise. And firmware as bytes. Okay, and so this I can return. Of course, normally you would query your hardware or whatever for the firmware, and then for the serial number, I say it's, you know, okay. Now I get creative. This is my serial number. Okay, and I want to return OPC-UA. Good. Okay, let's rebuild. Okay, and now I want to run the server, and I have to rebrowse here. And you see there's a new method, get diagnostics, and I can call this thing. And I call it, and I think this is what I wanted to see. I mean, I see my binary object like as my byte string and the serial number, as you can see. So, so here we talked about methods, and methods are primarily for invoking actions on real-life things expressed by OPC-UA. And remember, when CCUA it doesn't work, but still I'm showing this because there will be plenty of applications where methods will be the most natural thing to do. And actually there will be a few applications where methods will be the only thing you can actually apply to solve a particular problem, especially when you need to pass some arguments to get the return value. Then, you cannot really do that using variables, or you cannot do this, in a well-formed design. So anyway, I hope you liked that, and I hope to see you in the next part.